So let's do a vector field example. We'll find the flux of the vector field F equals yzi minus xzj minus xyk through the, call this a parabolic cylinder. So y equals x squared, so there's no condition like on z, or z is not part of this. And so we'll look at this for x between 0 and 1 and z between 0 and 3. So that's graphed here. And oriented so that the normal vector points in the negative y direction. So again, recall we need to have an orientation of this cylinder in order to talk about this integral. Okay, so let's start by parameterizing the cylinder. I'll leave up the definition of the vector field. So since z and x are sort of independent variables, we'll take r of xz to be xi plus, and then y is x squared, so x squared j plus zk. And that gives r x cross r z is, so this will be 1, 2x, 0, 0, 0, 1, I, j, k. So what does this give us? So I, this is 2xi. For j, we've got this, so minus j. And for k, okay, so no k component. And notice, so this is the cross product. And notice since we've got a negative coefficient in front of the j, this is pointing in the negative y direction. So this is agreeing with the orientation that we specified on the cylinder ahead of time. If we had asked in the original problem for pointing in the positive y direction, then we would need to take negative of this guy. Okay, so for the flux, we found that we had a simplified formula for the flux. So the integral of f over this surface is going to be the same as the integral of the box product of f dot this. So that will be integral z from 0 to 3, x from 0 to 1 of yzi minus xzj minus xyk dotted with dotted with 2xi minus j, and dx dz, which is integral 0, 3, integral 0, 1. This should give us 2, and y is x squared. Okay, so this will become 2x cubed z, and then plus xz, and then there's no k. This dx dz, this is integral 0 to 3 of, so integral x cubed, this will x to the 4 over 2. So this will integrate to 1/2, and x will also integrate to 1/2 from 0 to 1. So this is just integral from 0 to 3 of z dz, which is 9 over 2.